shows your chances of surviving to various ages once you reach 60. Chances of 60-year-olds surviving to various ages. Okay, so the age of 70, about 86%. To get to age 80, about 60%. To get to age 90, about 24%. And to get to age 100, it's about 2.7%. And they're giving us two functions. And they don't tell us which one is a better model. They're giving us the function and they're asking us to find f of 70. Now, can anyone tell us what will f of 70 represent? Or g of 70? It doesn't matter. What would it represent? How will I get it? How do I get f of 70? I have f of x equals negative 2.9x plus 286. How will I get f of 70? We talked about evaluating functions. How will I do that? Please help, anyone.
Would you plug 70 into the equation?
That's it. Here is the easiest way that I highly recommend. I go to y equals, clear if you have anything else in there, clear completely, and enter these two functions, one after the other. Negative 2.9x plus 286. Negative 2.9x plus 286. The next function. 0.01x squared minus 0.9. So 0.01x squared plus, and that was, no, minus 4.9 and plus 370. Minus, oops, (4.9x) plus 370. I'm going to check one more time. Negative, so it's 0.01. It was, I put positive. Yeah, I put positive. Minus 4.9x plus 370. Now I have, once I have both functions in here, I will get the answer right away. I don't need to calculate anything. I don't need to perform any calculation. I put second and table. I plug in 70, and instantaneously I get both answers. So I will write f of 70 is 83. F of 70 is 83. And of course, percent. And g of 70 is 76%. And again, so I have this in writing for you. This is problem 101. It's easier when you look at it later on, hopefully. Okay, so with the first function, with function f of x, at f of 70, the percentage was 83. The percentage was somewhere here at 83. The actual is 86. With g, with function g, g of 70 was 76%, which is here. For this situation, when x is 70, we are 60 right now. What are the chances that we get to 70? With the first function is 83%. With the second function is 76%. For the age of 70, which of these two modules is model 1 or model 2 is better, or gives us a better approximation of the actual percent? Is it f of x? Is it a better model, or is it g of x? Anyone, please? So the actual value, the actual percent is 86. Which of these two modules is a better module for reaching age 70?
First one.
Of course.
That's
Of course. Better. In other words, closer to 86%. That's why the first model is better. Okay. I think we have our idea so far from what we need from this section. So let's continue.
Can you plug that into the calculator again?
Yes,
one more
yes,
time?
yes,
Thank you.
sure. Let's do it. So you want me to go back to y equals and just type this in again?
Yeah, I see that, but when it comes up, I'm looking at X's and there's no 70, it's just 72. So I'm just confused. I want to see what you have.
So,
my question.
yes,
Whatever.
So-
I'm gonna need help because the first day when you put our settings, I don't my stuff. I need to set.
that's okay.
I'll
That's
meet you. I'll meet you another time. I'll write this department down. I'll come to
So let me tell you what happened. We have to go first. If you remember, we talked about this, but maybe you didn't do it at that time, which is fine. We go to second and table set. If you do not have the independent variable in the ask mode, the calculator will not allow you to put in the number you want. So you have to make sure that the independent variable is in the ask mode. Once you change that into the ask mode, then second and table. So Brand, I'm going to mute you. I'm sorry. It's only because I hear myself. Please unmute yourself when you want to talk. Okay, so go back. So only now I can enter with second and table, and I can enter 70. If I don't have the independent variable in the ask mode, the calculator will not allow me to do that. Is this okay now?
I can just meet you at a different time because now it's not coming up with anything.
But you have to enter 70. So you have the cursor here. You have to enter 70 and press enter.
Okay, gotcha.
So now you get 83 and then 76. Is that correct?
Mine says 83 and 414.
Okay, let's take a look. That's okay, no worries. Did you have 0.01 x squared? Do you have minus 4.9 x?
Yes.
And do you have plus 360? I'm sorry, plus 370?
Yes.
So you have this correct, like this?
Yes.
Okay, let's go back to second and table. And if you enter 70, so let's go back one more time. Clear everything from clear the second function. Clear.
Okay.
So enter 0.01 x squared, but you have to use this squared here. So it's x squared minus, do not use this minus symbol. You have to use the operational minus. 4.9x plus 370. And I'll go one more time to second and table and enter 70.
Okay, yeah, now it comes up with 76.
Perfect, awesome. Sometimes I make a mistake, so if nobody else checks, you know, who knows? So if there is a discrepancy, I'd like to catch it sooner rather than later. Good, other questions here? Other questions? Okay, so I wanted to continue now with section 2.2. more about functions. A lot of properties, a lot of things that we can say about a function. In addition to domain and range and finding values and so on and so forth. So here's one. Relative max or min. What does that mean? So a function, and I'm going to just show a graph, and then we'll go back to the book. So let's say I have this graph. So as you see, the function goes up till this point, where it's a relative maximum, then drops drastically to even negative values till this point, which is a relative minimum, and then it starts increasing again. This point is considered a relative maximum. Why? Because it looks like this. All points to the left, all points to the right are smaller in y value. All points here, they have a lower y value than this one. All points here have a lower y value than this one. That's why this is a relative max. Sometimes we also talk about absolute. What is the absolute maximum for this function? This one is. What is the absolute minimum for this function? This one is. But for now, we are looking at the relative max and min. So the function must exist on both sides. That's a must. This cannot be a relative minimum because the function does not exist on this side. But this one, the function exists on both sides, and the function values are smaller than this one. That's why this is a relative max. Here, it's this situation. In other words, the function exists on both sides, and all function values are larger than this function value. So that's a relative max, that's a relative min. Okay. Now, also notice, and I'm going to put some numbers here. I'm going to say this is 1, this is 2. I'm going to say this is 10. I'm going to say this is 11. Notice something very interesting. So this is item 2, a second thing that we can tell about the function. The function is increasing for these x values, not from which value to which value. No, 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 no. The trend of increasing, or the increasing trend, is from 1 to 2. Also, an increasing trend is from x equals 10 to x equals 11. So we write this. F is increasing on, and we only use parentheses, 1 comma 2 union 10 comma 11. Can anyone give us the interval on which the function is decreasing? Can anyone give us the interval on which the function is decreasing? We're only talking about x. Anyone, please?
Is it 3?
The interval. The interval is between 2 and 10. The function is decreasing for all x values between 2 and 10. Do we see that? So it was increasing on the interval 1 comma 2, also increasing on the interval 10 to 11, and it's completely decreasing from 2 to 10. Do we see that? Do we see that?
Yes.
Perfect.
Yes.
Perfect. Let's take a look. I want to go to I want to go to my page is 251. Let's use any function from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and identify where the function is increasing, decreasing, or constant. And in addition, we will also identify when it has a relative max or a relative min. So, anyone would like to choose? Anyone would like to choose? Any graph? If not,
14.
which one?
14.
14. We didn't get to 14 yet, but that's fine.
Oh.
That's fine. That's fine. It's perfect. Okay, so we want to look at 14 and we want to identify the intervals for this function where the function is increasing and where function is decreasing. So this is 14 on page 251. Perfect. So notice that there is an arrow here. So then the function does this. And here the function does this. Then can anyone identify the relative minimum? The point that is the relative minimum? This one. And another point that is a relative minimum. And another point that is a relative maximum. Maybe we should start with that. Can anyone identify the relative minimum?
-3.
As a point, correct. -3 comma.
B.
-3 comma. The point is here.
It would be -1.
Perfect. And the other relative minimum, please.
Three and 1.
3 and 1. Perfect. Can anyone now identify the relative max?
0.02.
Very good. Awesome. Excellent. So once we identify the relative max and the relative min, where the function is increasing and decreasing should be a piece of cake. So this was 7 and this was 8. Okay. So here is the function, something like this. You said -3, -1, and you said 3, -1, and you said 0, 2. Perfect. So the function is something like this. Good. So you gave me this -3, you have this 3, this is -1, and this is 2. Perfect. So can anyone identify where the function is increasing and where the function is decreasing? And I will put the arrows for you. Decreasing, increasing, decreasing, increasing. So the function is increasing, and remember we only look at the x values from this to this and from this to this and from this to this and from this to this. So can anyone tell us where is the function increasing? On which x intervals is the function increasing?
-3,
to
1,
negative
0.
3, exactly, -3 to 0. It's increasing from -3 and 0. From x equals -3 till x equals 0, the function is increasing. Union, it is also increasing from,
3 to infinity.
yes, perfect. Now the function is decreasing from this till this, and from this till this.
-3 to -2.
Negative
Or-
infinity till -3, negative infinity till -3, from x equals negative infinity till x equals -3, and it's also decreasing from
0
to,
to 3.
exactly. So remember, they're all parentheses, no brackets, because we are talking about the trend. So I will say the trend between 0 and 3 is decreasing. The trend between -3 and 0 is increasing. The trend between 3 and infinity, increasing. The trend of this function from negative infinity to -3 is decreasing. Perfect. Was a very good pick. Okay, just a quick question here. For this graph, can anyone identify the intervals, just the intervals for which the function is constant? Not increasing, not decreasing. I just want the intervals of constant for number 11 on page 251. Constant. The interval or intervals. Can anyone give us the intervals? For which this function in 11 is constant. Not increasing, not decreasing.
-infinity
Yes.
to -2.
Indeed. Union
With the union to 4
to,
infinity.
that's it, brilliant. So from negative infinity till this point, when x is -2, the function is constant. Then it's increasing. But then from 4 to infinity is constant again. Excellent. Very good. Thank you. Good. So now, what is the extra that we found out or learned about the function? We learned how to identify relative max-min. We learned how to identify increasing, decreasing intervals. So let me write it also in words. Increasing or decreasing or constant also intervals. Remember, they are always open with parentheses, and you are not asked to from which y value till which y value. No, 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 no. The trend between x equals 1 and between x equals 1 and x equals 2 is increasing. The trend between 2 and 10 is decreasing. Just the trend. Okay? So we learned how to determine relative max-min. We learned how to determine increasing, decreasing intervals. The next item is more stuff that we can learn from the graph of a function. Or it's important to know about a function. Symmetry. Symmetry, what is that? There are two functions have two different types of symmetries. Okay. Something called odd, which has nothing to do with odd numbers, like 1, 3, 5. No. Odd. And the other one is even. Has nothing to do with numbers like 12 and 14 and 16. No. So we say a function is odd if its graph, if the graph is symmetric with respect to the origin. What origin? Of the coordinate system 0, 0. So a function is odd or called odd. That has nothing to do with numbers or it's curious or something. No, no, no. It's called odd when its graph is symmetric with respect to the origin. We'll look at examples in a minute. It's called an even function if the graph is symmetric with respect to the y-axis. How do these graphs look like? Here's one. And here's another. One for each. Symmetric with respect to the origin. Symmetric with respect to the y-axis. These two pieces are mirrored images with respect to the origin. These two pieces are mirror images with respect to the y-axis. This function is called an odd function, and this function is called an even function. Let's look at a few graphs.